Yeah, hello everyone. I warmly welcome you to our webinar today on the topic Rethinking Tools to Assess Impacts from Dairy Farms Beyond Greenhouse Gas Emissions. My name is Nina Grasnik. I am, together with Klaus Deblitz and Jelto Zimmer, co-leading the Farm to Regional Scale Integration Network, which belongs to the Global Research Alliance on Agricultural Greenhouse Gases, the GRA. And in the Farm to Regional Scale Integration Network, we develop and apply methods for assessing the feasibility and economics of measures to reduce greenhouse gas emissions at the farm level and to upscale these results to the regional scale. And for further information on our activities, I will also put the link in the chat for the website of the GRA so you can read more about our activities. And before we start, I would like to inform you that this webinar is recorded and shared at the GRA homepage afterwards. And the presentation slides of our three speakers will also be uploaded. If you have a question during the webinar, please feel free to write it in the chat box so we can discuss it with the speakers during our panel discussion, or raise your hand so you can see the function down on the bottom of your screen, and we will unmute you during the panel discussion. Yeah, and with this, I would like to hand over to my colleague Titus Abdini, who's supporting us with the coordination of the Farm to Regional Scale Integration Network and will moderate the session today. So over to you, Titus.
Thank you, Nina, and thank you for the introduction. Hello, everyone. I hope you all are in a good conditions this afternoon or this morning, everywhere, wherever you're joining. My name is Titis Abdini. As Nina introduced, I'm supporting FRS network, and now especially because we are also aiming to soon or later develop a dairy group working, and maybe this is a good start for us to talk first about the assessment from dairy productions. I personally very excited for this event because we all know that the notions of including more indicators for impact assessments from dairy productions are getting more popular nowadays, so we get more nuances about the role of dairy production in our food systems. And although most of the time GRA people might see it as focusing only on greenhouse gas emissions from agriculture, but we are starting to opening up and embracing the ideas that there are more impacts that we should consider beside greenhouse gas emissions, and see what are the synergies to reduce the emissions, also the trade-offs, and which one that that is useful for policymaking, because we also want to contribute to the global agenda in preventing climate change or climate change adaptations. And dairy productions is very important, and dairy producers especially, they all want to moving toward more sustainable dairy systems. So we have three speakers this afternoon. First, I would like to introduce them one by one later before they started the presentation. Our first speaker is Dr. Catherine Pfeifer. She is leader of the group of agri-food systems at the Research Institute of Organic Agriculture, Switzerland. She has been working on transdisciplinary processes for resilient farming systems. That's what I understood from her publications. And she has vast experiences in spatial modeling. And this time, she will share focusedly on her work regarding with impact assessment on livestock production systems. So she will share about the alternatives or the recent developments of modeling to assess impacts from dairy productions. And for all of you who have questions along the way, please do share in the chat. We will have a discussion after three speakers share their presentations. Okay, Catherine, the floor is yours.
I got the technicality. So thank you very much for the introduction and for the invitation today. I wanted to bring a very different perspective to your webinar today and look and take a more, not really the farm vision, but looking or taking this farm system, the food system perspective, and show you how taking a food system perspective is actually changing the vision of what should be the most important thing we look at when we look at livestock. To do so, I actually was still asked to ask why it is so important to measure greenhouse gases and why for the dairy system. That's the first thing I want to look. Then I want to show you what are the usual ways that are used to measure impacts from livestock farms. Then discuss with you what is overlooked when we do when we use the eco-efficiency or the LCA approach. And then I try to show you a bit the narratives that we have in the organic sector, which shows basically what it means to take a food system approach. And it basically is about using livestock to close cycles and what we can gain from that. And then I want to really convince you by the end that despite of everything that is being said today, ruminants are a critical part of the future solution, and dairy has a very particular role in that. And therefore, maybe we should not forget about that when we talk about greenhouse gases and livestock. The first was, so why should we measure greenhouse gases? And this is one of the classical pictures we always see from FAO. Well, humans produce greenhouse gases, and when you look at the center, 15% of it is livestock. And so if we want to achieve any net zero or Paris agreements, we need to work on all dimensions, and livestock being so prominent on this graph shows that we also need to look at livestock. The usual ways we measure livestock we measure the impact or the footprint of a product is life cycle assessment. And here I've taken I took a study from Germany, a very nice study, that compares actually organic and conventional dairy systems. And really, the really interesting part, and coming from organic, is to let you know, well, look at this graph. Organic performs less good than conventional. And I want to look at why is that so. And this has a lot to do with eco-efficiency. So when we are trying to measure a per animal or per unit of well, let me start again. If we measure the efficiency or when we measure greenhouse gas per liter of milk, for example, then organic is less efficient. Organic is less efficient because we need more space for less animals. We try to feed them on more grass and less other feed. And as a result of that, it is less efficient to have organic animals compared on the right-hand side to the conventional one. So when we are measuring with life cycle assessment, we are measuring eco-efficiency. So how can you produce many liters of milk with the least possible impact on the greenhouse gas? And so that's what you measure. And that is a very important measure, but maybe it is not the only one. What I find very interesting also is that these studies highly depend on the methods you use, because I played around. This is not the original study. This is the other, this is a study that I adapted. And what you see, it's highly dependent on the method, because if you add soil carbon, then organic suddenly outperforms the conventional agriculture. And soil carbon measurements are still very contested. We are not very sure about which is the right method to measure. And so we see this is highly dependent. And now we change our conclusion just by adding another component in our analysis. Well, it goes further. This eco-efficiency, we use it for many other things too. We use it for land use, and that's one of them on the left. You see, there's the classical narrative that will tell you, well, you can feed one person with 2 fields with livestock, or I don't know how many there are, 14 if you go plant-based. Again, an eco-efficiency. On the right side, you see eco-efficiency on water for your sandwich, and what you're going to see is that animal source products need much more water than the rest. Again, eco-efficiency. Well, what it overlooks is that you can produce very efficiently with very little greenhouse gases, a lot of milk, and yet you might not be within the carrying capacity of the planet. And that's something this eco-efficiency is not considering, and that's something we think we should not lose in sight. Efficiency is important, but you should also remain within planetary boundaries. And here I took a graph from Company Al that looks at these planetary boundaries, and the black dotted points will show you the impact of agriculture. And I think that's quite, and I would say agriculture in general, not even livestock, the whole sector. And what you see, the first thing that is striking is climate change. Yes, we are not doing well, but we are in the yellow, we are not in the red. Whereas we are in the red for genetic diversity, nitrogen and phosphorus, and the contribution of agriculture to those to exhausting these planetary boundaries is tremendous. So here comes the question, well, is this focus on greenhouse gases really the big thing, or aren't we basically overlooking something? And so here you see that arrow, which I want to say, let us just for a while forget about the greenhouse gases and try to understand the nitrogen flow in the food system, and imagine a world where we solve the production within those planetary boundaries. And so I represented this with this graph where we see here in the middle, I hope you see my arrow, we have crops, and we actually grow them with 2 inputs. We can use fertilizer, but we can also use the manure. We create crops which can feed people, but we also feed livestock, who then gives us animal source product and therefore contribute to food and to human well-being. And on the other hand, we have the livestock also eating the grasslands and bringing back manure into the system. Well, if we want to sort the nitrogen problem, well, there is different, sorry, this goes too quick. We can imagine a world without animals, right? That's what the vegan narrative we hear all the time. Without animals, we will not have any healthy diets for the population, at least for a part of the population. We won't have the manure, so we will rely on artificial fertilizer, and we know that this is less good for soils than manure, and then nobody is using the grasslands. So if you ask me, that doesn't look like a really meaningful system. Grasslands are not used, we're losing soil fertility. On the other hand, we could sort this nitrogen problem from not using artificial fertilizers. Yes, this is something we understand very well at FiBL. This is organic agriculture, and though I am coming from the organic agriculture, I need to tell you, well, you know, organic produces 20% less than conventional, so it's not really a solution because we will need more land. And as we see here on the planetary boundary, we are already exceeding, and much more than climate, the land use that is required for our food system. So I also think just going organic will not work, and therefore we actually use the concept of circular food system. A circular food system is one where we try to keep only to put animals at the center and say we will keep those animals that will help us close any cycle in the food system, and that's quite easy. Human beings do not eat grass, therefore we put animals on it. When we do crop, we have crop residues, we have quality issues, so that's sort of waste that we can feed to animals. As we go in the value chain, we might have waste products we can feed to the animals, but we will just keep the amount of animals that can be fed without competing with human beings. And that's basically about improving the efficiency of our food system. And this will probably allow to reduce the fertilizer uses, but probably not without. And that's the type of research we're doing, and we are building models to calculate that. So we can't tell you if we can go completely fertilizer free because we haven't results yet, but that's what we are looking at. So how big is that issue today about feeding, well, we call this feed no food to your animals. These are data that were taken from Motet et al, and it shows you what is being fed to animals. And on the right-hand side, you see the poultry and the pork, and you see that actually everything that these animals eat are in direct competition with human consumption. Whereas when you look at the ruminant side, only 1/3 of it is in competition with human consumption, and the rest is grassland. And so, though they have similar inputs, or they provide the same amount of proteins, the ruminants are much less in competition with our food system, and allows us, or we understand this as being more sustainable because it helps us to reduce the footprint of the food system as a whole. We think that is really important, and so on the grassland you can actually you can improve efficiency, yes, and try to restrict poultry and pork when it's not fed on waste, and decrease the use of concentrates for ruminants. Well, then we stand there with all this grassland story, and we feel, oh, what shall we do with the grassland? Well, we understand ruminants, non-ruminants. We found this paper, which I don't even want to go fully into the detail, but what you see is the conversion efficiency. So how much from the protein do you get out from the product that went into the animal? Well, clearly those animals or these products where we think are in direct competition with human perform, like poultry performs better. But if we try to, if we try to look at what ruminant provide, then dairy has the better conversion factor, and therefore we suggest that grassland should be whenever used for dairy first, and have a beef production that results from the dairy system, just because we can produce more proteins through dairy than through beef. Sorry, this is not moving away. And then I wanted to close, well, if we have this strong focus on ruminant and suggesting that we should move away from pork and put this dairy system back on where it should be, we want to raise awareness that there's a huge debate in the science arena on whether methane, which is the biggest part of the greenhouse gas emission from ruminants, should be accounted for. And here there's a paper that suggests that the warming effect from methane is actually not important when the numbers of animals reduce. And we are saying basically we need to reduce the number of animals because we have a problem with nitrogen. Well, if we reduce these numbers of ruminants because of that, then you probably sort the climate problem automatically, especially in a world where you recognize that methane might not be shouldn't be weighted as much as it is today. So that was in summary for the debate afterwards. Narratives is based on eco-efficiency is only part of the story. We should look at planetary boundaries. We think that circularity is really core to sustainability because we can recycle waste, we can make an optimal use of grasslands, and we don't think it's such an issue in a warming in terms of greenhouse gas emissions. That's from my side, and I'm really looking forward to the hot debate because I think that's not what you were expecting.
Thank you, Catherine. That was insightful, and perhaps for us in GRA, you won't be very popular because you bring another insight into us, or perhaps you will add more tasks to another global research alliance for a different indicators in the within planet to check the planetary boundary. And I'm also personally looking forward to see the results of your modeling to that, because that's also relevant to our Green Deal, EU Green Deal, about the farm to fork strategy. They really want to use to reduce fertilizer and boost more organic agriculture. So yeah, good luck with that. In the meantime, please hold on your question or just write it on the chat. I will introduce the second speaker. Our second speaker is Dr. Alan Rotz. He is agricultural engineer from the United States Department of Agriculture, sorry. So Alan has been developed and used the models to assess impacts from dairy and beef production, and of course, continuously investigating on different measures to reduce impacts from dairy and beef productions. So Alan, this time you will share particularly about your work in different regions of USA. I think that's the most of the talk, but yeah. Okay, we can see your presentation, and now over to you.
Okay, good. So yeah, I'm going to be talking about our work primarily in the United States, looking at dairy farms, both at the farm level and particularly how we're using farm level simulations to really look at regional and national environmental assessments. So there are many emissions that do come from dairy farms. Some of the more important ones, of course, is greenhouse gases. There's a whole group of compounds that we just lump as VOCs, volatile organic compounds. They're important in some regions and in some conditions. Ammonia is a very big and important one. Hydrogen sulfide is an important safety kind of issue, but it's not so much an environmental issue. And of course, we also have the nutrient runoff, losses into surface waters and leaching into groundwaters. So really to do a good assessment, we really need to take a comprehensive look at the whole production system and all the different environmental impacts. And that's what we're trying to do. So we not only include all the components here as shown on the farm, but as was kind of indicated in the previous session, for doing a life cycle assessment, we also need to look at what we call the upstream impacts. Those environmental impacts that are occurring as we produce fertilizer, equipment, electricity, fuel, so forth, that are used in the production system. We also have to consider what we often refer to as indirect emissions. And so when different emissions from the farm transform, particularly nitrogen is an important one, transforms in the atmosphere and deposits in other locations, causing environmental problems. So the tool that we're working with is the Integrated Farm System Model. This is a tool that's been under development, verification, and application for quite a few years now. Looking at both dairy and beef production systems. And this tool is somewhat unique in that it's a process level simulation of the whole farm production system. So we're simulating each of these components, often on a daily time step, looking at the flow of nutrients and materials throughout the system, the interaction that occurs among the different components, and ultimately the emissions and the resources that are being brought, the emissions that are leaving and the resources that are coming into the system. We usually simulate farms over like 25 years of weather to get a long-term look at the performance, environmental impacts, and we can also look at economics of the farm. In terms of environmental impacts, then the model predicts, of course, greenhouse gas emissions. We're also looking at ammonia, hydrogen sulfide, VOCs, as indicated earlier. We have denitrification and losses as N2 and NO2 as well as N2O, leaching of N, and a runoff of nitrogen and phosphorus, and then doing an overall farm balance of the nutrients. So we're using the model to look at farms, and we can do a life cycle of what we call farm gate life cycle assessment, looking at all the impacts up to the point where the milk leaves the farm. And then we're also doing some further simulations where we feed the output basically of the farm model into more standard life cycle assessment software such as SummerPro and OpenLCA, where we can do a more comprehensive life cycle assessment, as was kind of indicated and described in the previous presentation. In terms of farm assessments, we've done many different types of assessments, looking at the farm productivity and environmental impacts of specific farms, comparing production systems, really looking at them, what can we do to make things better, looking at the benefits of different mitigation strategies. We've also done some projections into future climate, looking at how future climate would affect farms and how we can change the management to adapt to that changing climate. What I'm going to spend the rest of the time on then is this regional and national assessment, which I think is of particular interest. So what we've done is divide the United States into 6 different regions. Each of these has somewhat different climates and different production strategies. So what we've done is to go into each of those regions, model representative operations throughout the region, assess the environmental impacts of each of those using the Cradle to Farm Gate LCA in IFSM. Then we total those values across the regions and then across the country, weighted by the amount of milk that would be produced, what the proportion of the milk produced by each of those individual operations, how that proportion is for the total region, and then ultimately to the total nation. So that's how we're doing it. And just to show some of the numbers, in terms of greenhouse gas emissions for milk production in the United States, we're finding about 1 kilogram of CO2 equivalent per kilogram of fat and protein corrected milk produced. And as indicated, there also among the regions, this varied from a low of 0.9 to a high of 1.2, just because of regional differences and management differences in the region. For individual production systems, it varied from 0.7 to 1.5. And the pie chart sort of shows the breakdown. Most of the largest portion of the emissions is from enteric emissions of the animal. Another 25% from manure, and 17% it comes from feed production. That's basically N2O emission from the fields that are producing feeds for the animals and so forth. So when we total that across the United States, it's a little under 100,000 gigograms of CO2 equivalent. And you can see it's kind of distributed across the regions, pretty much in proportion to the number of animals and the amount of milk produced in each region. What this represents, and if we compare this to the total U.S. inventory of greenhouse gas emissions, about 1.5% comes from dairy farms in the United States. And within the regions, this was varied from a low of 0.3 to a high of 3.4%. We take this to the full life cycle now, going through processing and consumption by the consumer, waste treatment, and so forth. The number is a little larger, particularly when we're now looking at it per kilogram of milk consumed. The number is 1.8 kilograms of CO2 equivalent per kilogram of milk consumed. And you can see here in the green, about 3/4 of this is from what occurs on the farm, and then the others is somewhat equally distributed between processing, transportation, retail, and the consumer. If we compare this to the national GHG inventory, it's about 2%. Perhaps a more important thing to look at is reactive nitrogen, as we just saw in the previous presentation. Kind of feel that this is probably a little bit more important for the long-term sustainability of dairy farms. And you can see here by the pie diagram that the major contributor to this is ammonia emission from the manure being produced. If we look across regions, the source and amount of ammonia emission does vary, primarily as influenced by the climate and the management of the region. So in our western part of the country, which is shown more on the right, we're mostly looking at open lot dairies and of course warmer temperatures and things, which leads to greater emissions. The total ammonia emission is what we came up with was 610 gigagrams of nitrogen. And again, you can see it's kind of distributed across the regions, somewhat similar to what greenhouse gas emissions was distributed. And it's related to the amount of milk produced. If we compare this to the national inventory, we're looking at about 24% perhaps of the total ammonia emission in the United States coming from dairy farms. And this varied from a low of 5 to a high of 76% as we looked at it on individual regions. Quick look at VOC emissions. Again, this is a distribution. Now we're seeing the Midwest actually coming out a little higher in proportion to all the rest. Where VOC emissions are actually the most important, though, is in the Central Valley of California. That's where they're getting the most attention. The attention will probably grow through other areas of the country as well. We compare this to national emissions inventory, it's about 1.7%. And look at phosphorus loss. Again, here in the Midwest really comes out as a large contributor due to the fairly wet climate, a lot of precipitation, some flooding events and that sort of thing, a lot of tillage and cropping system, not so much grassland and that sort of thing, which all leads to greater loss. So just to wrap this up, some take home, I guess greenhouse gas emissions, of course, are important and they've kind of become the focus. I'm not necessarily sure they should be the primary focus. I think reactive nitrogen and particularly primarily ammonia losses may be a more important consideration in the long-term sustainability of dairy farms. And of course, nitrate and phosphorus runoff losses can also be important, particularly in the eastern United States and in more wet areas. Eutrophication of surface waters has become a very important problem. So VOC emissions in some locations, particularly like the Central Valley of California, just because of the configuration of the terrain and so forth, they tend to be a greater issue. We didn't talk much about hydrogen sulfide. It can be a very important safety issue. We have people dying pretty much every year when manure storages are stirred. Large amounts of hydrogen sulfide can be released, which can be very toxic to those in the area. Other than that, though, their relative importance on the environment overall, it's very small coming from dairy farms. So there are trade-offs which occur, and I feel that that's why we really do need to do a comprehensive life cycle assessment to really fully evaluate and compare the impacts of different production systems and so forth, which goes along with what the previous presentation said as well. So with that, thank you.
Thank you, Alan. Very informative one. Of course, the United States is very big with the different problems in different regions. I believe that it's communication also needed to deliver such an information to a different stakeholders. Well, we will move forward to our third speaker. She is Dr. Monika Zehetmeier. She has been working at the Bavarian State Research Center for Agriculture in Germany. And we have been talking a lot about environmental indicators, but now Monika will bring a new, fresh perspective from the economics and also give us some examples of measures that she investigates what is the most cost-effective measures for certain dairy productions, especially in Germany. Okay, Monika, over to you.
Yeah, thank you very much, Titis, and thank you very much for the opportunity to present our work today. Yeah, very warm greetings from Bavaria, where the sun is just going down behind me there. So it's just the other way around than for you. Yeah, insights from the LFL Klima-Check. And I will focus today how we moved from a tool that was originally an economic tool to link it with greenhouse gas emissions and what we learned from it and which way we want to go further to select cost-effective greenhouse gas mitigation options on dairy farms. So first of all, I would like to show you how we can distinguish different tools that are available to assess greenhouse gas emissions. And I think Ellen just showed us a very, very detailed tool that has a very high degree of farm level assessment. So you can really assess the whole farm. But I guess, and I think Ellen would agree, you need a lot of data to fill this tool and to get a full inventory. And just for some examples, a Swiss tool, Salsa it's called, it's again a very detailed tool where you can see the whole farm and you can assess the whole life cycle assessment. On the other hand, we have the Cool Farm tool where you can assess a carbon footprint. It's also farm level, but as there is always a trade-off between data needed to go into the tool and user friendliness, the Cool Farm tool especially tried to give a balance that the farmer is not overwhelmed with data needed from the farm to assess a carbon footprint. But if we want to move forward to see, yeah, what is not just the carbon footprint, but where can the individual farm and the individual farm system find greenhouse gas mitigation options, there a very detailed assessment is needed. And what we tried with our LFL Klima-Check is to make these degrees very variable for the user, for the advisors, and also for research, so we can play around as much as possible. What you see is you can start, like here, with a farming system to look at the dairy farming system of a farm if you have a mixed system, but then you can step by step link together different plant production systems to assess a whole farm approach. And on the other way around, you can get a result without putting any data into the tool, as it is filled with lots of default values. But you can replace all the data with own farm data. So you can go into very much detail if you like. And this is both important for economics as for greenhouse gas emissions to identify mitigation options. So to summarize, I would like to summarize now, the tool, and then I will show you some results where we played around with the tool. So you can do a farm-specific assessment, a very detailed life cycle inventory. You can do what-if scenarios, so you can play around. If you have the farm as it is, you can do scenarios, and this is only possible if you have a partly mechanistic tool and if you have default values. You can do a joint economic and greenhouse gas assessment, and you can move from the production system to the farm level and also beyond the dairy farm level. It is open access, which is especially important for our research, so we can have a bidirectional knowledge transfer. All our research knowledge is going into it, and the user that is using the tool gives back information to us when he works with the tool. Just a small spot on the tool where you can see how it looks like. So it's open access, it's web-based, and in the first side you see from the tool, from the dairy farm part, you see, you can choose between different breeds of dairy cows, and then you see different production traits. And what you see is that for each breed, and if you switch the breed, also these default values will change. For each breed, you have a lot of default values that are already in the tool, and these are typical German and Bavarian production traits of different breeds and dairy farms. But you can replace all these data with your own data from your own farm. So step by step, you can build your own farm as deep as possible, and things will change on economics and on greenhouse gas emissions. And it's always the same procedure if you go for economics or for greenhouse gas emissions. So you can gain from loads of synergy if you have one tool to assess both, because for example, for plant production systems, 100% synergies if you need the same input data for your own farm as you need for economics, as you need for greenhouse gas emissions. So with one data input, you can get two results. You have loads of synergies on data input. For the dairy cow production systems, if you want to do a full cost analysis and a greenhouse gas emission assessment, you might need 20% more data for greenhouse gas emissions. So if you do the full cost assessment and then again 20% more data to get an additional, so 80% is synergy data used for economics and for greenhouse gas emissions. Yeah, so I show you some results. If you go for a default value for a typical Bavarian dairy cow production systems, you can get different, and I focus now on the greenhouse gas emissions. You see the different parts of greenhouse gas emissions that you get per cow and year. You see one part is heifer rearing, then calf rearing emissions, methane emissions from enteric fermentation. Then you have the emissions from feeding. This is feed production, a whole life cycle assessment, and also from feed losses. Then you have methane and dinitrogen oxide emissions from nitrogen application, mineral and organic, water use, and diesel consumption on the farm. And this is the typical system where you have where we come up with a carbon footprint of 1.35 kilograms CO2 equivalent per kilogram milk if we put all to the milk. And if we distinguish then a different allocation method, the IDF allocation method, we come up to roughly 1 kilogram CO2 equivalent. I guess it's very similar to the results that Ellen showed. Yeah, and now we can start to play around with the tool, as it's partly mechanistic, so we can start to change different values and see what happens on the economic part and on the greenhouse gas emission part. And for the first part, you can see we changed the manure storage system and we applied an anaerobic digestion. 90% of manure goes to the anaerobic digester. Then we changed, for example, the energy content of the grass silage from 6.0 to 6.6, so higher quality of grass silage per kilogram dry matter. And we reduced the replacement rate. So with this measures, and what we also did is to replace the protein source from soybean abroad to a homegrown protein source. And with these measures, we succeeded to reduce the carbon footprint from 105 to 1.08 kilograms CO2 equivalent. And you can also see that the gross margin is all variable costs included, increases from 28 cents per kilogram milk to 29 cents per kilogram milk. And this is what we very often see if we want to improve the greenhouse gas emissions on the dairy farm, assuming a constant milk yield, and I come to this in the next part. We can see that there are many synergies for greenhouse gas emissions and economics, and this is really the door opener for all advisory services and farmers to get interested into greenhouse gas emission tools and to learn more about it. because this is, I think, one of the main challenges at the moment also to get this topic into the practical farming. Yeah, I said so far we looked at the system with a constant milk yield. And what is also important is to look beyond the dairy farm gate. And why is this so? I have a little example here. If we have, the typical, and this is especially important for Bavaria, if you have the typical Bavarian dual-purpose dairy cow and you have a specialist dairy cow, the usual spot is that you look at an LCA on the dairy farm gate, and at the dairy farm gate, calves are sold at about 8 weeks and go to beef production systems. But at this stage, the fattening potential of this calf is not yet there. You cannot see it yet. It's a bit, the weight is a bit higher, but the potential is not seen at this farm gate. So what you need to do is to do a combined milk and beef consideration. And for that, it's important that the tool not just stops at the dairy farm gate, but also gives you the possibility to link the bull fattening or the heifer fattening system to your dairy system to make a whole system approach. And if you do so, in the tool, you can see one example. If you start with the dual purpose system and you switch to a specialized milk system, at the dairy farm gate, you see a reduction of greenhouse gas emissions per cow. But if you go the long way up to the end of the beef production system, you see that you have a little bit higher emissions from bull fattening here. But if you want to have the same amount of milk and beef, yes, you can add different beef production systems with the specialized milk breed, and at the end you can come up with higher greenhouse gas emissions. And I think this is very similar to what Catherine has told us at the beginning. If you link milk and beef production, it's a very efficient way to produce milk and beef. But at the dairy farm gate and from an economic perspective, it's not shown on this border of the tools. So you have to move the long way till the end of the fattening of the calf that this potential is shown. And I think New Zealand showed a very nice example. They went a very long time to separate dairy and beef production systems and are now trying to integrate dairy and beef production systems to reduce the greenhouse gas emission at national level. Yeah, to summarize, these detailed economic and greenhouse gas assessment tools can identify farm-specific hotspots. And the data inventory can give you a lot of synergies if you do a combined greenhouse gas emission and economic assessment. So with one farm data pool, you can really get two results for the farms. And if you move the next step to not just show what are the hotspots, but what is the leverage if we change something on our farm, we can see, or our tool showed us that for our farming systems, about 10 to 20% on average greenhouse gas mitigation potential can be achieved with cost-effective measurements, which is a better replacement rate and better efficiency of feed production along the way until the feed reaches the cow. And economics is a door opener for advisory service. We can get additional mitigation options with technological measures, which I said is anaerobic digesters, but these are mainly costly, intensive, and need other incentives to be adapted by the farms. And if we want to identify mitigation measures beyond the dairy farm gate, a joint milk and beef consideration is necessary. And for the long term, we have now assessed in the tool greenhouse gas emissions and economics, but for the long term, to avoid leakage and to really identify meaningful greenhouse gas mitigation measures, we need a whole bundle of more indicators, which is especially when it comes to greenhouse gas emissions, carbon sequestration. And yeah, it's not very good that at the moment there are many different ways to account for that. So this would be really needed that research gets a joint assessment there, and also an assessment that is really verified. Then land use and feed food competition was also mentioned by Catherine, would be important indicators in the search for greenhouse gas mitigation options, product quality. And I think it would be very nice if we can start to think about indicators that link the farm and the regional level. Yeah, with that, I thank you for your attention, and I'm looking forward for the discussion.
Thank you, Monika, for the nice presentation. That was actually really eye-opening when you said about integrating beef and dairy, because I think it's also applicable for many regions where dairy systems is not solely proposed for milk productions, and they have multi-purpose as well, not only for milk but also beef production, and of course for manure production in some smallholder farmers that still rely on the fertilizer from cattle. Well, from that point, I also see the many questions already on the chat, and I think my first question that I want to pick is more a technical thing regarding the tool. For all speakers, do you see any application of approach or the tool that that now you presented for other regions, not only for Europe or North America, but also somewhere in other region? I think that's one of the questions from Sega Ndao. If those tools are also potentials in other region, for example, in Africa. Do you want to answer, Alan or Monika? Or maybe even Catherine, you have some experience in Africa as well. Please.
Well, I guess in terms of our model, the integrated farm system model, we've used it in a number of different parts of the world, but they're all sort of more temperate climates, let's say. Certainly United States, Canada, and many parts of Europe, New Zealand, Australia, some parts. Africa, probably not. Their production systems would be just so much different from our technology and things that I don't see much application for Africa.
Yeah. What about Klima-Check tool, Monika?
Yeah, I think it's very similar. So European systems and American system, I think they can be quite adapted. But if it comes to very specific plant production systems or breeds or technologies, then I think it's very, it needs, especially the default values would not be available.
Mm-hmm. Any additional comments on this question, Catherine?
Yeah, the models that we see in Europe, they are on, and probably the US, but I won't advance myself too much on the field, I don't know, are usually using a lot of parameters that are available for Europe. And what you see happening is when we start really measuring on the ground what's going on in Africa, you realize that the parameters that are in IPCC and put in for Africa are about the tenfold of the reality. And I think that's something we shouldn't look away, that there's really good ongoing work that reviews these standard parameters, and it's quite shocking how different the reality on the ground is. This being said, yes, for the parameters, just our tools are not useful because of this discrepancy of data. When you work in organic, we work much more in mixed systems and in things that are integrated, and our models are quite complex. So I think the ideas behind the models that are developed here can be applied to more extensive and to still more traditional systems in Africa, but the parameters we put in need to absolutely be replaced or retested because it's nonsense to use our parameters for Africa.
Yeah, so we definitely need more inventories on other parts of the world. I would like to move forward to another question about allocation. It's always a debate when we are doing LCA, of course. Can all of you share your experience and opinions about allocations, not only allocations of the emissions from the products of the dairy farming systems, but including allocation of the inputs when you consider it as an input for the dairy production systems. Somebody wants to start? Maybe Alan?
I guess in general for dairy, when we are evaluating dairy production systems, we're using the IDF model, International Dairy Federation, what they've published, where what we're allocating between milk and potential beef products by the I mean, it comes down to a mass, but it's basically based on the somewhat physiological differences and things in the allocation method. But that's what we use, and I guess we do a lot with beef as well. And whenever you look at what's coming in to the beef chain from dairy, I mean, any animals that we can get from the dairy industry are just a tremendous help in reducing the footprint of the beef system.
Yeah. And Monika, there's also additional question for you if you consider economic value of manure when you allocate emissions to milk, beef, and manure, perhaps.
Yeah, we also applied the IDF approach. So the new IDF approach success not to apply an allocation for manure. So far we do not. We have it within the economic part. We give it a value. As certainly it has a value actually with the high mineral nitrogen fertilizer prices. And but for greenhouse gas emissions, we apply the IDF approach, so there is no allocation for manure. But of course, for milk and beef, and yeah, those who know me, I am really since 10 years. I keep saying like that. I'm not a fan of any allocation method between milk and beef because I think it really doesn't matter which allocation method we use. As at the dairy farm gate. These calves are not do not show their potential yet. And as Ellen said, we only see it once we start to calculate the beef production systems. So, and once we really calculate milk production systems and beef production systems, it doesn't matter which allocation method we use because it weights out at the end. And so I think, yeah, it's nice to have an allocation method just to give a carbon footprint, but if we want to really decide which mitigation measures we should use, which mitigation options, we need to play around with allocation measures and we need to go beyond the dairy farm gate, just to make sure that we see the whole picture.
Okay, Catherine, any comments on that?
Really, I think everything has been said, and we use the same allocation for our farm level work.
Mm-hmm. Yeah, I also agree that it's always more considerations needed to decide which allocation that we need. It's 4 o'clock already, so I can see there are some questions that I don't pick up front, but we will go to a deep dive sessions for 15 minutes. So every participants, you can choose which breakout room that you want to enter. So the breakout room is divided for different speakers. And in that breakout room, you can use the time to get into the detail, to get the detailed answers from different speakers. I think the breakout session is now ready.
Yeah, I will. I think I first want to close the webinar for everyone who wants to leave now and not participate in the deep dive. So from the Farm to Regional Scale Integration Network, again, I want to thank all the speakers for presenting your insights on existing GHG tools and pointing out the importance of not only focusing on GHG emissions, but think beyond and also consider other environmental indicators such as reactive nitrogen and economics and so on. I think it's great food for thoughts for the work that we have planned also in our dairy working group in the Farm to Regional Scale Integration Network. So yeah, thanks a lot. And since we still have some questions open here, I think that's a great opportunity. As Tita said, we have planned a deep dive session right now, 15 minutes with all 3 speakers. And I will open